According to the National Electrical Code, Section 424.3b, circuits supplying vital equipment, such as furnaces, shall not be connected to any other equipment. This code requirement exists because the dedicated circuit is designed to provide uninterrupted power to the furnace, ensuring its safe and reliable operation. Terminating the feed into a four-way outlet would compromise this dedication and could potentially cause power interruptions to the furnace. To safely connect the furnace to a standby generator, it is recommended to use a transfer switch that is specifically designed for this purpose. A transfer switch allows you to switch the furnace's power source from the house supply to the generator during power outages. The transfer switch should be rated for the voltage and amperage of the furnace circuit. It should also have a manual or automatic transfer feature. Always follow the manufacturer's instructions carefully for proper installation and operation of the transfer switch. Furnaces typically require 120 volts power, so a generator without a 220 volt side can still be used. It is always important to refer to the furnace and generator manufacturer's instructions for specific requirements and recommendations regarding power supply and generator connections. When working with electrical systems, safety is paramount. If you are not comfortable working with electricity, it is best to consult a qualified electrician to ensure the safe and proper installation of a transfer switch. The National Electrical Code, or NEC, is a set of standards and guidelines for the safe installation of electrical wiring and equipment in the United States. It is developed and updated by the National Fire Protection Association, or NFPA, and is widely adopted by state and local jurisdictions. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is important to follow the NEC guidelines to ensure the safety of people and property. Article 424 in the NEC covers fixed electric space heating equipment. Part 3 of Article 424 addresses branch circuits. Section 424.3 covers the branch circuit requirements. Branch circuits for fixed electric space heating equipment shall be sized in accordance with 210.22c. Electric space heating equipment and branch circuit conductors shall be protected by overcurrent protective devices sized in accordance with 240.4 and 424.22. Section 210.22c pertains to the permissible loads of a branch circuit. A branch circuit supplying a single motor-operated appliance shall be sized according to Part 430.22 and other sections in Article 430 that may apply. Branch circuit sizing requirements in 430.22 cover single motor applications. Section 240.4 covers the protection of conductors. Conductors, other than flexible cords, flexible cables, and fixture wires shall be protected against overcurrent in accordance with their ampacities specified in 310.15 as adjusted where applicable. Overcurrent protection for flexible cords and flexible cables shall comply with 240.5. Overcurrent protection for fixture wires shall comply with 240.5. Section 424.22 covers overcurrent protection. Electric space heating equipment employing resistance type heating elements rated more than 60 amps shall have the heating elements subdivided. Each subdivided load shall not exceed 48 amps and shall be protected at not more than 60 amps. These supplementary overcurrent protective devices shall be 1. Factory installed within or on the heater enclosure, or 2. Located immediately adjacent thereto. The disconnecting means shall be readily accessible and suitable for disconnecting all ungrounded conductors of the heating circuit. The branch circuit overcurrent device shall be permitted as a disconnecting means where readily accessible for electric space heating equipment employing resistance type heating elements rated not more than 60 amps. Section 424.3b states that circuits supplying vital equipment, such as furnaces, shall not be connected to any other equipment. The intent of this requirement is to ensure that vital equipment receives uninterrupted power. Connecting other equipment to the same circuit could potentially cause power interruptions to the vital equipment, which could have serious consequences. A transfer switch is an electrical device that allows you to switch between two different power sources. In the case of a furnace, a transfer switch can be used to switch between the utility power and a generator. Transfer switches are available in two main types: manual and automatic. A manual transfer switch requires you to manually switch between the two power sources. An automatic transfer switch will automatically switch to the generator when the utility power is lost. Transfer switches are rated for the voltage and amperage of the circuit that they are connected to. It is important to choose a transfer switch that is properly rated for the furnace circuit. Transfer switches must be installed in accordance with the manufacturer's instructions and all applicable electrical codes. It is best to have a qualified electrician install a transfer switch. When selecting a generator for use with a furnace, it is important to consider the power requirements of the furnace. The generator must be able to provide enough power to start and run the furnace. The power requirements of the furnace can be found on the furnace's nameplate. It is also important to consider the type of fuel that the generator uses. Generators are available that run on gasoline, propane, or natural gas. Choose a generator that uses a fuel that is readily available and that you are comfortable using. The generator should be located in a well-ventilated area to prevent the buildup of carbon monoxide. Never operate a generator indoors or in an enclosed space. When connecting a generator to a furnace, it is important to follow all safety precautions. Always disconnect the utility power before connecting the generator. This will prevent the generator from backfeeding into the utility grid, which could be dangerous. Use a heavy-duty extension cord that is properly rated for the power requirements of the furnace. Connect the extension cord to the generator and then to the transfer switch. Start the generator and allow it to warm up before switching to the generator power source. Monitor the generator and the furnace to ensure that they are operating properly. If there are any problems, disconnect the generator and call a qualified electrician. Grounding is an important safety measure that helps to protect people from electric shock. Electrical equipment should be properly grounded to provide a path for fault current to flow back to the source. This will cause the circuit breaker to trip, which will interrupt the flow of electricity and prevent electric shock. Grounding can be achieved by connecting the metal parts of electrical equipment to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode must be properly installed and connected to the electrical system. Grounding can also be achieved by using a ground fault circuit interrupter, or GFCI. A GFCI is a device that detects ground faults and interrupts the flow of electricity. GFCIs are commonly used in bathrooms, kitchens, and other areas where there is a risk of electric shock. Overcurrent protection is another important safety measure that helps to protect electrical equipment from damage. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity when the current exceeds a safe level. Circuit breakers and fuses are rated for the amount of current that they can safely carry. It is important to choose circuit breakers and fuses that are properly rated for the circuit that they are protecting. If a circuit breaker trips or a fuse blows, it is important to investigate the cause of the overcurrent before resetting the circuit breaker or replacing the fuse. Overcurrent can be caused by a short circuit, an overload, or a ground fault. Electrical safety is a critical aspect of any electrical installation. By following the NEC guidelines and taking appropriate safety precautions, you can help to ensure the safety of people and property. If you are not comfortable working with electricity, it is best to consult a qualified electrician. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before making any electrical installations or repairs. Remember that working with electricity can be dangerous and should only be done by qualified individuals. Always take the necessary safety precautions to protect yourself from electric shock. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. The use of a transfer switch is the safest and most reliable way to connect a generator to a furnace. A transfer switch will prevent the generator from backfeeding into the utility grid and will ensure that the furnace receives uninterrupted power. When selecting a transfer switch, it is important to choose a switch that is properly rated for the voltage and amperage of the furnace circuit. It is also important to follow the manufacturer's instructions carefully for proper installation and operation. The NEC provides detailed requirements for the installation of transfer switches. It is important to consult the NEC to ensure that the transfer switch is installed in accordance with all applicable codes. Working with electricity can be dangerous. If you are not comfortable working with electricity, it is best to consult a qualified electrician. An electrician can safely install a transfer switch and ensure that the furnace is properly connected to the generator. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before making any electrical installations or repairs. Remember, safety should always be the top priority when working with electricity. Never take any risks that could put yourself or others in danger. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. The National Electrical Code is a comprehensive set of standards for electrical installations. It is important to be familiar with the NEC if you are working with electricity. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is important to follow the NEC guidelines to ensure the safety of people and property. If you have any questions about the NEC, consult with a qualified electrician. Working with electricity can be dangerous. Always take the necessary safety precautions to protect yourself from electric shock. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. The generator you are considering should have sufficient capacity to handle the furnace's starting and running wattage. Check the furnace nameplate for this information. The transfer switch isolates the generator from the utility lines, preventing backfeed, which is a dangerous situation that could harm utility workers and damage equipment. Ensure the transfer switch is properly grounded according to the manufacturer's instructions and local electrical codes. If you're unfamiliar with electrical work, hire a qualified electrician to install the transfer switch and connect the generator. This ensures the job is done safely and according to code. Before operating the generator, familiarize yourself with its controls, safety features, and maintenance requirements. Keep the generator well maintained to ensure reliable operation during power outages. Always operate the generator outdoors in a well-ventilated area, away from windows and doors, to prevent carbon monoxide poisoning. Install carbon monoxide detectors in your home to provide an early warning of dangerous levels of this odorless, colorless gas. Store fuel for the generator safely away from heat sources and in a properly labeled container. Have a fire extinguisher nearby and know how to use it in case of a fuel-related fire. Regularly test the generator to ensure it's working properly and that you're familiar with its operation. This is especially important before hurricane season or other times when power outages are more likely. Consider a whole house surge protector to protect your appliances and electronics from voltage spikes that can occur during power outages and generator use. The size of the transfer switch depends on the amperage of your main electrical service. Consult a qualified electrician to determine the correct size for your home. There are two main types of transfer switches: manual and automatic. Manual transfer switches require you to manually switch between the utility power and the generator. Automatic transfer switches automatically switch to the generator when the utility power is lost. Automatic transfer switches are more convenient but also more expensive. Some generators have a built-in transfer switch. If you're buying a new generator, consider one with this feature. Before using a generator, make sure all major appliances are turned off to reduce the load on the generator when it starts up. Let the generator warm up for a few minutes before connecting any appliances. Avoid overloading the generator, as this can damage the generator and the appliances connected to it. Monitor the generator's voltage and frequency to ensure they are within the acceptable range. Use a multimeter to check the voltage. If the voltage is too low or too high, adjust the generator settings accordingly. If you're using an extension cord to connect the generator to the transfer switch, make sure it's a heavy-duty cord that's rated for outdoor use. Check the extension cord for any damage before each use. Never run the generator unattended. Check on it periodically to make sure it's running properly and that there are no leaks or other problems. When the power comes back on, turn off the generator and let it cool down before storing it. Disconnect the generator from the transfer switch and store it in a dry, well-ventilated place. Regularly inspect the generator for any signs of damage or wear. Replace any worn or damaged parts. Follow the manufacturer's instructions for maintaining the generator. This includes changing the oil, cleaning the air filter, and replacing the spark plug. Keep a log of all maintenance performed on the generator. This will help you track its performance and identify any potential problems. Consider purchasing a generator cover to protect it from the elements when it's not in use. Store the generator in a secure location to prevent theft or vandalism. Consider a generator monitoring system that will alert you if there's a problem with the generator. This can be especially helpful if you're away from home when the power goes out. A generator interlock kit is a less expensive alternative to a transfer switch. However, it's not as safe or convenient. An interlock kit allows you to connect the generator to your home's electrical panel, but it requires you to manually switch off the main breaker before connecting the generator. Never connect the generator directly to your home's wiring without using a transfer switch or interlock kit. This is extremely dangerous and could cause a fire or electrocution. If you're not sure whether a transfer switch or an interlock kit is right for you, consult with a qualified electrician. They can assess your needs and recommend the best solution for your home. Before installing a transfer switch or interlock kit, check with your local building department to see if a permit is required. Some jurisdictions require a permit for any electrical work. The generator should be sized to handle the essential loads in your home, such as the furnace, refrigerator, and lights. You don't need to size the generator to handle the entire load of your home. Calculate the total wattage of the appliances you want to run on the generator. Add a safety factor of 20% to account for the starting wattage of some appliances. Choose a generator that has a continuous wattage rating that is greater than or equal to the calculated wattage. Consider a dual-fuel generator that can run on gasoline or propane. This gives you more flexibility in choosing a fuel source. Propane is generally more expensive than gasoline, but it has a longer shelf life. Store propane tanks outdoors in a well-ventilated area. Never store propane tanks indoors. If you're using gasoline, use a fuel stabilizer to prevent it from going bad. Store gasoline in a tightly sealed container in a cool, dark place. Check the gasoline periodically and discard it if it's old or has a sour smell. Never mix oil with gasoline unless the generator is designed to run on a mixture of oil and gasoline. Use the correct type of oil for your generator. Check the owner's manual for the recommended oil type. Change the oil regularly, following the manufacturer's instructions. Keep the generator clean and free of debris. Clean the air filter regularly to ensure proper airflow. Check the spark plug periodically and replace it if it's worn or damaged. Lubricate the generator's moving parts to prevent wear and tear. Store the generator in a dry, well-ventilated place to prevent rust and corrosion. Cover the generator with a top or other protective covering to protect it from the elements. Disconnect the battery from the generator if you're not going to use it for an extended period of time. This will prevent the battery from draining. Charge the battery periodically to keep it in good condition. Before starting the generator, make sure all connections are tight and secure. Check the fuel level and add fuel if necessary. Open the fuel valve and turn on the choke. Start the generator according to the manufacturer's instructions. Let the generator warm up for a few minutes before connecting any appliances. Monitor the generator's voltage and frequency to ensure they are within the acceptable range. If the generator starts to overheat, shut it down and let it cool down before restarting it. If the generator makes any unusual noises, shut it down and have it inspected by a qualified technician. If the generator is smoking excessively, shut it down and have it inspected by a qualified technician. If the generator is leaking fuel, shut it down and have it repaired immediately. Never operate a generator that is leaking fuel. Carbon monoxide is a deadly gas that is produced by generators. Never operate a generator indoors or in an enclosed space. Install carbon monoxide detectors in your home to provide an early warning of dangerous levels of this gas. If you start to feel sick while operating a generator, get to fresh air immediately. Seek medical attention if you suspect carbon monoxide poisoning. Always follow the manufacturer's instructions when operating a generator. If you have any questions or concerns, consult with a qualified technician. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or technician before making any electrical installations or repairs. Remember, safety should always be the top priority when working with electricity or generators. Never take any risks that could put yourself or others in danger.